So, hello everyone, my name is Leevi Kotilainen and in this presentation we'll be going through my master's thesis, which was about adaptability in ventilation and its financial feasibility in new office construction. So what was actually studied? So the research question for my thesis was how do different attributes of adaptability in ventilation systems affect the net operating income and investment costs of an office space in new construction? And with this, the attributes of adaptability was identified through literature review, and these were identified to be air distribution, which is the adaptability in distribution of airflow through ductwork channels and inlets/outlets. Accessibility, which was how ventilation systems are accessible to maintain or replace. And then oversizing, which means the oversizing of airflow rates to current needs. Then controllability, so basically how controllable / smart is the ventilation system. And then at last technical circulation, so the reuse and circulation of ventilation system parts. And through these attributes of adaptability, it was modeled how these would affect the NOI and then the investment cost to see if these investments into ventilation adaptability would be financially feasible. So how was this actually studied? So the study method that I chose was a case study, and this case studied an existing space of 2.4 thousand square meters of a newly built office building in the HMA area. And for this, a 10-year DCF model was made for the existing space with its existing attributes of ventilation adaptability, which was called the base case. And then this case was compared to different scenarios of the mentioned attributes of adaptability in the last slide. And a 10-year model consisted of reconfiguration processes that occurred when a lease matured. And these reconfiguration processes consisted of adding meeting rooms and enclosed workspaces to the existing open plan space. And this was done to measure the needed adaptability within the 10-year calculation period. And this is showcased in the picture on the right. Then the study compared the different scenarios of the attributes of adaptability, financial KPI deltas to the base case of the space to see if higher or lower levels of certain ventilation attributes of adaptability would yield better KPIs than the base case. And the KPIs selected were the value of the space by the value of the discounted cash flows and then IRR. So the results of the case study are summarized in this slide. So different scenarios of the different attributes of ventilation adaptability were studied, starting off with the air distribution. So in here, the scenario was either increasing/decreasing the air distribution by the number of vents in the initial construction of the building and the space. So this was found to have small financial effect and no direct impact on net operating income. And a higher level of air distribution resulted to higher upfront costs, but save in reconfiguration costs. But as said, these changes to the base case were really small. Moving on to accessibility. So in here we studied a scenario where we used a raised floor to distribute air instead of the suspended ceilings, which were used in the base case. And this was found to have a much higher upfront and reconfiguration costs. And suspended ceilings are more cost efficient and more common in Finnish office stock. So basically using a raised floor is only done in the office construction when necessary. And basically using a raised floor was deemed to be inadaptable. Then moving on to oversizing. So in here we studied different scenarios of different levels of airflow distribution, and the base case already had an existing oversizing level of 20% to the space, and we noticed that a higher level of oversizing had higher upfront costs, but they save in reconfiguration costs. And the costs are saved basically because when meeting rooms are added, a lot more airflow is required for the space. And this means that if you have additional airflow by the oversizing, no larger kind of works has to be done in the reconfiguration processes, saving a lot of money. And in here, the existing 20% of oversizing was found most financially feasible. Of course, with a 0% oversizing, the initial investment would be a lot lower, but it would be really costly to make changes when the market or demands or tenant demands so. Then moving on to controllability. So in here we compare different airflow controllability systems, and the base case had a demand controlled ventilation system, so a DCV, and this was compared to a CAV system, which means constant air volume system. So the constant air volume system had lower upfront costs but higher OPEX, and the higher OPEX comes from the fact that it runs through a constant airflow rate. So when there's no demand for air, the air is still flowing, and this is why you have to pay for example, for energy costs, etc. It was also deemed that the tenants demand high levels of airflow rates, so a DCB that reacts straight to the oxygen levels in the air was deemed to increase tenant satisfaction, so that affects the rental income. So in the CAV system, it was the rental income was expected to be lower. And then lastly, technical circulation. So circulation, this was basically the circulation and reuse of ventilation system parts. And in here it was deemed that there was no financial impact within the 10-year calculation period, and the long-term period benefits are mainly environmental rather than financial after the 10 years. And the effects would come after the calculation period because in the ventilation system, the lifespan of each part is largely longer than the 10 years. What was actually learned? So it was learned that air ventilation has a big importance in terms of adaptability in an office space through the reconfiguration of the space. This affects the financial feasibility of the space, as ventilation adaptability makes reconfiguration of space cost efficient, increases the technical quality of the space, and increases tenant demands and the growing airflow standards in Finland. So at the end, I would like to thank Professor Heidi Falkenbach for her guidance and really informative and helpful comments during my thesis work. Then I would like to thank Alexander Saares for his great tips on the case study and a really good attitude towards my thesis and really helpful communication. And then overall, I would like to thank Aalto University and the Real Estate Economics program for the last 2 years.